Alright, I'm going to do a quick video on special right angle triangles, and there's two that I want to take a look at in particular, and it's 30, 60, 90 and 45, 45, 90. Now, as always, I encourage you to stop the video or rewind when you need it, but also, I think in this particular instance, once you kind of see what I'm going at, you should probably stop the video and see if you can finish up the proof on your own. What I'm going to do here is I'm going to start with the 60, 60, 60 triangle, which is obviously equilateral. And I'm going to just pick a value at random. And let's say I'm going to say the sides are all 10 centimeters. And so there you go. Now, if I draw the angle bisector from here straight on down, you'll notice that what I end up with is a 30-degree angle here. And this new side, which I'll do in blue, is obviously no, oops, that's not blue. This new side is obviously no longer 10. It should be half of 10, so it's now 5. So I'm going to redraw this picture, and it looks something like this. And, well, you know what? I'm going to try to draw this a little bit more accurate. It's going to look something a little bit more like that, and you're going to have to stretch your imagination here because obviously it's not drawn to scale. But take a look what I do know. I knew that my hypotenuse is now 10, and my base here is 5 centimeters, respectively. So if I wanted to find this side, I would say I'll call it A, because it's my altitude. Now, Pythagorean theorem tells us that A squared plus B squared equals C squared. I'm actually going to call it H squared. Well, that might not be the best idea either. I'll call it C squared. And C is obviously my hypotenuse. Now, I'm going to continue on. I'm going to say A squared plus 5 squared equals 10 squared. And when I do that, I get A squared plus 25 equals 100. I'm going to subtract 25. And I'm going to say A squared equals 75. I don't want the value of A squared. I want the value of A. So I'm going to take the square root of both sides. And remember, when you do the square root of A squared and you do the square root of 75, you'll get A on this side. And you're supposed to get plus or minus the square root of 75. Well, it's a length, so we neglect the negative value. Now, take a quick look. Radical 75 is really equal to radical 25 times 3. But I know the value of radical 25. The blah, 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 blah. Let me try that again using real words. The value of radical 25 is just 5. And I'm not sure what the value of radical 3 is, so I'm just going to call it 5 radical 3. So, take a look what happens here. The side opposite my 30 degrees was 5. My hypotenuse was 10, and now I get 5 radical 3. Well, that should make you think. I wonder if there's some kind of pattern here. I'm going to erase this. I'm going to move a little bit quickly through this proof simply because I have a whole another proof that I might have to do. And if I don't have enough time, I'll have to do it on a separate video. So let's take a quick look. I'm going to start again with the 30, 60, 90 triangle. And, oh my goodness, that is awful. I'm going to say, here we go. And I'm going to make this my 30. I'm going to make this my 60. So the one thing I am sure of is that this and this, if this is A, this has to be 2A. And the reason I'm sure of that was because if my sides were 2A, when I created that perpendicular bisector, that ended up becoming A. So A and 2A. So I'm left with this base, which I'll call X. So take a quick look, and this is where you might want to stop the video and try this proof out for yourself and see where you get. I'm going to use the Pythagorean theorem, and I'm going to use my parentheses very, very carefully. It has to be parentheses 2A, quantity squared. So I get x squared plus a squared equals 2A times 2A is 4A squared. I subtract 1A squared. Now be careful. A lot of people will then say it's 4, and that's a colossal mistake. It's understandable, but it's not correct. This is like 4 hot dogs minus 1 hot dog gives me 3 hot dogs. But since we're not actually using hot dogs, we're going to use 3A squared. Alright, now I'm going to take the square root of both sides, and when you do that, take a look at this. This is fantastic. I get the square root of 3 times the square root of A squared. I don't know the square root of 3, but I do know the square root of A squared, and that's just A, so I get A radical 3. So, what does that all mean? It means that this side opposite the 60 degrees is always a radical 3. So if a equals 5, it'd be 5, 10, 5 radical 3, which we showed before. But if a was 4, it'd be 4, 8, 2 times 4 is 8, 4 radical 3. And you can see that that's always true. What that also means is that all 30, 60, 90 triangles are similar triangles, and there's two reasons you know that. A, you can prove it by angle, angle. And B, you can show it because their sides, their corresponding sides will always be proportional. I have 5 over, oh, let's do another triangle here. Let's say that this was 4, 8, 4 radical 3. If I were to set up a proportion, I'd say 5 over 4 equals 10 over 8, which equals 5 radical 3 over 4 radical 3. And if you cross multiplied any pair, you'll see that they are equal. 5 times 8 is 40, 4 times 10 is 40. Therefore, the corresponding sides are proportional. All right, we're going to do the second proof real quick. And once again, I encourage you to stop the video now and try to do the second proof. How would you go about this? Well, I know that 45 and 45 form an isosceles right angle triangle. So I'm going to call this A, I'm going to call this A, and I'm going to call this X. So I'm going to say A squared plus A squared equals X squared. And that's because A squared plus B squared equals C squared, but my A and my B are the same value. Remember, they're opposite congruent angles, so therefore the sides are congruent. When I add A squared plus A squared, I get 2A squared, which equals X squared. I'm trying to find the value of X. So I'm going to take the square root of X squared, and once again, now I get square root of 2 times the square root of A squared equals just X. I don't know radical 2, but I do know that radical A squared is A, so now I get A radical 2 equals X, which means, if I erase that, this is going to be A radical 2. Now, I'm going to erase this. I'm going to plug in some numbers real quick. Let's say I had a triangle, and it was something like this. This was 45, this was 45, this is 3 and 3, and I wanted to find that. If I said 3 squared plus 3 squared equals X squared, I would get 9 plus 9 equals X squared. I have two groups of 9, which is 18. If I square root this, obviously I'm going to get radical 9 times radical 2, because 2 times 9 is 18, and we knew that anyway, equals radical X squared. So I get 3 radical 2 equals X. And once again, take a look. If A is 3, then this is 3, then this is 3 radical 2. If this was 5, that would be 5, that would be 5 radical 2. If this happened to be radical 2, this would be radical 2, this would be radical 2 radical 2, which is radical 4, which is 2. That also means that every single pair of 45, 45, 90 triangles are also similar because of, once again, angle, angle. This triangle has this angle and this angle congruent, this angle and this angle are congruent, so therefore the third angles are obviously congruent. But because of that's true, then the triangles are congruent. Also, their sides are always going to be proportional as well. That's it. That was a quick video. Wow, it was 9 minutes long, so it wasn't all that quick. But it's going to be quite helpful if you're doing special right angle triangles. I hope you enjoyed it. Good luck.